Okay, so just a couple more examples. If we want to find the area of this figure, lines that look parallel are parallel, dimensions are in inches. So as we look at this, we could see it as a trapezoid, which the formula is the sum of the bases, base 1 plus base 2. You take that times the height, and you divide by 2. Then you're going to add the area of half of a circle. So the area of a circle is pi r squared, but then you divide by 2. So I have that formula already up on the board. So as we look at it, if I want to find just the area of the trapezoid, my bases are 5 and 7. I take that times the height. The height happens to be the same as the diameter of the circle. If the radius is 2, you'd have 2 for the top, excuse me, the top vertical segment, and 2 for the bottom vertical segment. So that diameter is the height, which is 4. And then you would divide by 2. So that's just the area of the trapezoid. If I continue with that calculation, 5 plus 7 is 12. So I'm going to have 12 times 4 and divide by 2. I'm going to divide first. So 2 goes into 12 6 times, and 6 times 4 means that the area of the trapezoid is 24, in this case, square inches. Now, if I look at just the area of the circle, it's a semicircle, so I have to take the formula for a circle, which is pi r squared, and I have to divide it by 2. Well, that looked really messy, so let's just start that over again. So the semicircle portion is going to be pi r squared, but since it's a semicircle, I'll go ahead and divide it by 2. The radius is 2, so I have pi times the radius, which is 2 squared, divided by 2. 2 squared is 4, so I have pi times 4 divided by 2, which you have to square the radius before you divide. Orders of operations say you do your powers before division. 2 goes into 4 2 times, so that gives you a value of 2 pi. So the area of my semicircle is 2 pi square units. To find the area of your whole figure, you're going to take the area of the trapezoid, and which is 24, and you're going to add the area of the semicircle, which is 2 pi. You can leave your answer in terms of pi. That's an exact answer, which mathematicians like. So it's 24 plus 2 pi square inches. Now, if you really wanted to, because you have that desire to know what that exact area is, you could do an approximation. Pi is approximately 3.14, so it's like 3. So 3 times 2 is 6. So you could say it's 6 plus 24, you get around 30. If not, you could go ahead and use the 3.14. And if I take that times 2, you get 6.28. So I'm going to take 24 plus 6.28, which is the 2 pi, and that gives you 30.28, which our approximation was 30. So it's approximately equal to, that's what the 2 squiggly lines means, 30.28 square inches. Either answer is correct. Just as you progress throughout your mathematics courses throughout here and then into college, they like to leave it in terms of an exact answer, which means in terms of pi. If we look at another example, let me back up. Instead of areas of trapezoids, which I already gave you a formula for area of a trapezoid in a previous video clip, what we want to know is what happens if I have a parallelogram. In a parallelogram, you have 2 pairs of parallel sides. It's a quadrilateral with 2 pairs of parallel sides. The key thing is when you say pairs. If I want to find the area of that, you need to envision dropping this down to get a right triangle, finding the height of your trapezoid, or of your parallelogram, sorry, finding the height of your parallelogram. And then if you were to take this triangle right here, this right triangle, if I were to take that and let me sit here and I don't want, okay, if I were to group those together, if I were to take that right triangle piece And let's say we chop it off, and what we're going to do is we're going to move that and slide it right over here to this position. So what I have done is I have removed this right triangle right over here. It's now gone. This piece is now gone. It no longer exists there. I moved it over here to this position. When you do that, the figure that is formed is a rectangle. And how do you find the area of a rectangle? That is going to be length times width, or base times height. So the area of a parallelogram is equal to length times width. Because you can make a rectangle out of it. Now keep in mind the height is still that perpendicular distance, or the width is still that perpendicular distance. So this is the width and here's the length. Don't let this slant distance be your length or width. It is not included in the calculations. Now we talked about the formula for area of a trapezoid. Some of you like to split it into triangles and a rectangle. That's fine. Sometimes people get confused though with what should X and what should Y be. Are they always equal? If you have an isosceles trapezoid, they are. An isosceles trapezoid would be where those two side lengths are the same. But if they're not isosceles, some people struggle with that. So you can always, don't worry, you can split it into two triangles and a rectangle. If not, we went back to what was stated earlier in a previous video, where the area for a trapezoid, which I used in the very first slide, the area of a trapezoid is the sum of the bases, where the bases are the parallel segments, times the height divided by 2. So your parallel segments are going to be your bases. Add them together, take it times the height. The height will be that perpendicular distance, not one of the two slanted sides. It is not this side, it's not this side. So keep in mind where your height is, and then you divide by 2. So one last example here. Find the area of this trapezoid. Dimensions are in meters. Once again, you could try to split this down, and if you do, then I know that this segment right here is 9. So if the full thing is 15, and just this bottom piece here that I have highlighted in blue is 9, then I have 6 left over. So this could be 3 and 3, which it is an isosceles trapezoid because I have those two lengths of 5. But some people struggle and they're like, oh, or is it 4 and 2? Well, that would also work, but they just get confused as they work through it. So we are going to try to find, we are going to try to find this by using the formula for the area of a trapezoid, which can help you get to the answer maybe at a quicker pace. I know you know another method to get to it, but this will be a method that you will need to practice, and it will become really quick for you. And then you can use it to help you when you get to some time test intervals, because you don't have to make calculations. I don't have to split it, the figure. I can just look at it. So as we go through the formula for a trapezoid, I have the sum of the bases times the height divided by 2. My two bases, 9 is going to be base 1. Oh, okay. And 15 is going to be base 2. I can flip them around, it's okay. It's just that my bases are going to be those parallel segments. So as I plug in information, oh, and your height happens to be 4. So as I substitute the information into my formula, I have 9 plus 15, the sum of the bases. I take that times the height, which is 4, not 5. Height is always that perpendicular distance, not a slant distance. So I have 9 plus 15 times 4 divided by 2. So if I want to make an easier calculation, or you need to add first, you can't reduce within the parentheses. So 9 plus 15 is 24 times 4 divided by 2. You could take 24 times 4, and then take half of that. I find it easier to divide smaller numbers, so I'm going to take 2 into 4, which is 2. You could take it into 24 to give you 12, but 2 goes into 4 2 times, and 24 times 2 is 48. Now, don't forget you are finding area, so your units are squared. So you end up with 48 square meters. And that's using the formula for trapezoid, which I think is going to be a lot easier after practice. Right now, you may want to resort to the rectangle and the triangles, but I would strongly encourage you to try to use that formula for a trapezoid.